Hello everyone, welcome back to mahafarkar.co.in. In today's video, we are going to deal with one of the important article called terminal velocity. टर्मिनल वेलोसिटी समजून घेण्यासाठी एक छोटेसे एक्सपेरिमेंट इमॅजिन करा. पोहता येत असेल तर ट्राय पण करा. इमॅजिन करा तुमच्याकडे एक मोठी विहीर आहे. इट इज वेल डेप्थ, त्याची भरपूर डेप्थ आहे आणि त्या विहिरीत तुम्ही जंप केलात. तुम्ही जेव्हा जंप करणार तेव्हा तुम्हाला असं लक्षात येईल की सुरुवातीला तुमची स्पीड कमी 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 होत गेली आणि त्याच्यानंतर इफ यू हॅव नॉट एक्झर्टेड एनी फोर्स, तुम्ही जर कुठलीही मुवमेंट त्या विहिरीत केली नाही, तुम्हाला पोहता येतं असं गृहीत धरून मी हे सगळं सांगतोय, अदरवाईज डोंट ट्राय. तर तुम्ही जेव्हा विहिरीच्या डेप्थकडे जाणार आहात, बॉटमकडे जाणार आहात, देन यू विल फील दॅट आता तुमची स्पीड एक ठराविक डिस्टन्स नंतर कॉन्स्टंट झाली. जर तुम्हाला एक्सपेरिमेंट करून बघायचं नसेल स्वतःच्या जीवाशी, ड्रॉप अ स्टोन ड्रॉप करा. सुरुवातीला तो स्टोन जसा जसा काही लेयर्सना पेनिट्रेट करेल तसा त्याची वेलोसिटी हळूहळू कमी होईल आणि एक ठराविक डिस्टन्स नंतर इट इज इन टू द वॉटर, इट इज इन टू द लिक्विड. आफ्टर सर्टन डिस्टन्स इन टू द लिक्विड, वेलोसिटी विल बी गोज ऑन constant throughout. Acceleration acting on that object is what? Zero. When it is happened, then we will say that the velocity is which velocity? Terminal velocity. So if I want to define the terminal velocity, then what I can say in the definition? The constant velocity attained by the spherical body or body when is moving in the viscous fluid. Okay, so the constant velocity attained by body when flowing or falling in viscous fluid. Okay, the constant velocity attained by body when falling in the viscous fluid is called as which velocity? Terminal velocity. So we are going to find the formula for terminal velocity when a spherical ball of certain material is falling freely into the viscous fluid, any fluid, water or any kind of different fluid. So let's write few things. So let r be the radius of that object which is falling freely into the liquid. Say v is the initial velocity of object. We have not considered that it is directly a terminal velocity. Okay, let rho be the density of that object. Now these things are related to object. Now it is falling in the viscous fluid, so let sigma be the density of fluid. Sigma is what? Density of the fluid, and say eta is the coefficient of viscosity of fluid. Okay, these are some fixed things that are not going to change. And finally say g be the acceleration due to gravity present at that point. Okay, now what we are going to discuss is the important factor. When object is moving in a downward direction, the only force acts on the object is the gravitational force. But when it is entered on the different, suppose that ball initially have entered here, so this layer of liquid must have opposed its motion. So that force which is exerted by liquid surface in upward direction, we call this which force? Buoyant force. Again, every relative layer of liquid is trying to exert the same force, then it is again which force there? Viscous force. So we are going to discuss the forces. So the forces acting on the object. Here we have restricted our studies to the object which is spherical in a shape. So acting on the object are, the first force is the downward force, and this downward force is contributed by which force? Definitely which force? Gravitational force. And we know that when object is moving under gravity, this gravitational force is nothing but the weight. Therefore I can write downward force is nothing but weight of object. Okay, so it is equals to, say, Fd, that is downward force, is equals to m into g. Say this is the weight of the object. Now second force. Now when object is falling under the gravity, I said you already that every layer of liquid exerting force in upward direction, so it is trying to provide which force? Viscous force as well as what? Buoyant force. So upward force is contributed by buoyant force and viscous force. Okay, so upward force, I will write upward force can be equal to buoyant force. If you remember, in the 9th standard you have learned Archimedes principle. If suppose object is dropped into the liquid will spill out of the container. How much liquid spills out? Then if you find the weight of that liquid, then that weight of the liquid is equals to what? Buoyant force exerted by the liquid on the object. So if you remember this, I can say weight of liquid that spills out of the vessel, okay, plus say viscous force. So weight of liquid is say m dash g plus viscous force. If you remember Stokes law, then according to Stokes law it is 6 pi rv eta. So this is equation number 2. Now we are going to slightly modify equation 1 and 2 in terms of densities of the object. So to modify them, okay, now we have density of object can be written as density of object. Say rho is equals to mass of object divided by volume. V is the volume. So mass can be equal to rho into volume. Say object I said is spherical. Sphere has radius r. So what should be the volume of that object? So I will say rho into 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of that sphere. So this is equation number 3. And density of fluid can be equal to sigma equal to m dash upon same volume will be released. So m dash equal to sigma, not rho, sorry, it is sigma into 4 by 3 pi r cube. So this is equation number 4. These 4 equations are the basic of the entire article. Now what I said, object is falling inside the fluid. Initially its velocity goes on decreases. Velocity goes on decrease means what is happening? One force coming in a downward direction, another force in upward direction, both are opposed each other. In that case, the force which is dominating initially is the upward force, so that velocity of object goes on or decreases. Once the dominating force, which one was the upward force, and the downward force which is because of gravity, both are leveled, then object now has resultant acceleration 0 because of its interaction, and then purely the gravitational force acts on the object. In that case, I will say one important statement now I can write that when object attains the terminal velocity, when object attains which velocity? Terminal velocity, that is v equal to say vt, then upward force acting on the object is always equals to downward force acting on the object. So this will be the most important term that we are going to use to find out the basic formula for terminal velocity. So now let's substitute the values in the formula for upward force and downward force using this equation 3 and 4 also. So if I put 3 in 1, then I can say this is downward force and this is say upward force. So I can say Fd can be equal to Fu. Fd is what? Mg, but value of M is what? So I will write directly rho into 4 by 3 pi r cube into g is equals to Fu. This means this one, but M dash again here is equal to sigma into 4 by 3 pi r cube g plus 6 pi r Vt eta. Why Vt? Now I have said that object have attained which velocity? Terminal velocity. बस substitute करना है और simplify करना है. See what we are going to get. First I am dividing both the sides by 2 pi. So if I divide it by 2 pi, say rho is as it is, 2 will be remain, pi is cancelled. 2 pi r. I am dividing both sides by 2 pi r. So here r will cancel. So r square over g equal to sigma. Here also 2 by 3 pi cancel और ये r square g plus here 3 pi cancel, r cancel, Vt eta. Shift this term towards the LHS. So what we are going to get? 3 Vt eta is equals to rho 2 by 3 r square g minus sigma 2 by 3 r square g. See what is common? 2 by 3 r square is common, g is also common. So 2 by 3 r square common निकला, rho minus sigma into g. This is value of what? 3 Vt eta. Okay, so 3 and eta can be shifted there. So Vt can be equal to 2 divided by 3 into 3, 9 eta into rho minus sigma into g. This is the formula for terminal velocity of an object when it is falling freely inside viscous fluid. This formula indicates that the terminal velocity doesn't depend upon mass. It is independent of mass. Independent. Okay. This velocity is directly proportional. So I have missed something in the final formula. Here r square is there. This formula is directly proportional to, so Vt directly proportional to radius square, Vt inversely proportional to coefficient of viscosity. So this is the article and the corresponding formula. Using this formula one can find eta also equal to, or I can get, if you know the terminal velocity, then eta equal to 2 by 9 times Vt into r square into rho minus sigma into g. So you can use this formula also to find coefficient of viscosity if you know the terminal velocity for that fluid. I hope you understood this article. Thanks for watching mahasarkar.co.in. Have a nice day. Thank you.